Hello! Okay, so this is actually the second time I'm making this video. The first time I had forgotten to change the camera selection to video, so I was on photo, I hit the button, ran over here, started recording, or not recording because it actually only took a picture, and so now I'm doing this again. I'm still in the same shirt as the last one, if you noticed that, because it's the same day. It's July 3rd. And we're going. I don't know if I mentioned the last one, but I'm planning on going to a Frederick Keys game with my family and watch some fireworks. Okay. So we're going to talk about the global energy budget, and that means we're going to be identifying where energy for the Earth comes from and where it goes on the Earth. Now, normally when we talk about the word budget, I talk about finances. Money, where my household, between my wife's income and my income, that's the money that we're bringing into our household, and then all of the things we spend money on, the mortgage, insurance, food, entertainment, all that stuff, that's the money we spend, and hopefully those two numbers are about the same. If the amount of money I make is a little bit more than the amount of money I spend, that's good. The other way around is not so good. So in as far as energy for the Earth, though, because of law of conservation of energy, it's impossible to get more or less energy than you start with. So that's a good thing. So we don't have to worry about balancing our budget, but we do need to talk about how energy on the Earth is related to climate and weather. That's ultimately what all of these lessons are going to be connected to, the climate and weather on Earth, and we need to start with where does our weather get its energy from? Because it takes energy to cause wind. It takes energy to cause water to rise up into the air and eventually rain back down. And it obviously takes energy to warm up the surface of the Earth. And where does that energy come from? That energy comes from the sun. Now, the largest percentage of energy that comes from the sun comes in the form of light. And that light can do one of three things. I don't know if that. It can reflect, it can absorb, or it can radiate. So when we talk about reflection, a lot of times we're talking about things bouncing off. I was out with some friends of mine the other day, and I was playing pool, and the pool balls reflect or bounce off the edge of the pool table. Some people, when they look in the mirror, they realize when they're looking in the mirror, the light bounces off the mirror surface. So a lot of times when we talk about the word reflect, I'm using the word bounce. Now, certain things are more reflective than others. Ice is more reflective than a blacktop, and so we'll talk about that and how that affects the temperature later on. Now, if you want to use a different word other than the word bounce, that's when we talk about energy from the sun bouncing off the Earth's atmosphere or the Earth's surface, that's what we're using. We're going to use the word reflect. Absorb means to take in or use up. Students of mine, at this point, they drew a little picture. That's my really bad picture of SpongeBob SquarePants. When sponges absorb water. Absorb when the land takes in the energy, then we can use it's bringing the energy in. It's sucking it in. That's what we're talking about when we're talking about absorbing. Radiate means to give off. Or to send the energy up, send the energy away. So if when we do diagrams later, and I draw the Earth's surface, Radiate would be the energy bouncing off. Absorb would be the energy just coming in and absorbing, not bouncing off at all. And radiate would be the energy leaving at a later time. Our energy budget, different from a financial budget, is the ways that the energy is going to be used and transferred on Earth, and how it's absorbed, and how much of it's being absorbed, reflected, or radiated. We're going to talk about percentages, where a certain percentage of energy is coming in, a certain percentage is bouncing off, or absorbing, or reflecting. So when we take a look at this picture of the Earth, and we think about light coming in, actually let me use a different color. Depending on where the light hits, different things might happen. For example, when light hits at an angle here, a higher percentage of it's going to bounce off. When light hits a cloudy area, percentage of it's going to bounce off. When light hits directly, more of it's going to be absorbed and less of it's going to be bounced off. So depending on where it's hitting on the Earth, what type of surface it's hitting, land tends to absorb more energy than the water does. And so that would cause temperatures to be different at those two different locations. So when we're talking about the location that you have for your environmentally friendly house that you're designing, where it's located might affect what the average temperature might be. So here's a little bit better diagram of that, where we talk about when energy's coming in, some of that energy bounces off the atmosphere, some of that energy reflects off the Earth's surface, and some of that energy is absorbed by the Earth's surface. And then later on, so that if you notice, daytime, the sun is hitting the Earth, light is some of it's being absorbed, some of it's bouncing off. During the nighttime, the Earth radiates that heat back into space, and some of that heat goes straight out into space. Some of that heat stays trapped in the Earth's atmosphere. Specific gases can trap that Earth's that heat energy, and we'll talk about that in just a moment. So, how does energy travel to the Earth? Energy travels to the Earth as blank waves. We call them electromagnetic waves, or we can even call it radiation. Now, electromagnetic waves include gamma rays all the way up to radio waves, in which visible light, and if we look at the colors, Roy G. Biv, red, orange, yellow, green, indigo, violet, we don't really talk, Roy G. Biv, oh no, I'm sorry, blue, indigo, violet, and so, but the sun gives off all of these, it gives off gamma rays, X-rays, ultraviolet, visible light, infrared, radios. Now, when we talk about where the energy comes from, and what type of energy heats up the Earth, we're going to focus mostly on ultraviolet, visible light, and infrared. Oops, sorry. So, Earth energy travels the Earth in the form of electromagnetic waves or radiation. And then when we talk about the two forms of radiation, not the two forms of radiation that we're going to be discussing, we're going to be talking about, we're going to divide them into categories of visible light versus non-visible radiation. Visible light includes Roy G. Biv, the colors. It's in the middle of the electromagnetic spectrum. Non-visible light, there's a whole bunch of non-visible radiation, like I said, gamma rays, X-rays, but the two ones that we're going to talk about most are infrared and ultraviolet. All right, so we have visible, which is light, all the colors. I'll even write Roy G. Biv right here. And then non-visible. In which we're going to talk about infrared. Now, infrared is going to basically, you can detect, your body's able to detect infrared as heat. So you close your eyes on a hot summer day and you feel that heat on your skin. That's infrared. And this is when we talk about at nighttime when energy is radiated back into space. Infrared energy is radiated back into space. Ultraviolet radiation is also a factor. Sometimes we call them UV rays. Small amounts enter the atmosphere that can cause sunburn, suntans, and skin cancer if you get too much. We actually have a layer of the Earth's atmosphere that's there, and it has the function of protecting us from ultraviolet radiation. We call it the ozone layer. Ozone is the formula for ozone is O3. Now, regrettably, in the last 50 years, we produced certain types of pollution that break down the ozone layer. So, because of that, the Earth has been getting more ultraviolet radiation than it has in the past, which means people have been having more skin cancer. And so the ozone layer, in the last 10 years, there's been a lot of legislation, a lot of changes that have occurred. So those gases that break down ozone have been being released less and less, but it's still an issue. So infrared is heat, while ultraviolet is you can't see it at all. Some animals and insects can see ultraviolet light, and ultraviolet light is also what damages your eyes if you look directly at the sun. So if you when you have sunglasses to help block ultraviolet light, you're protecting your eyes a little bit from that. You really don't want to look at the sun unless you can have something that really blocks 100% of the ultraviolet light. Now, surfaces that absorb and radiate energy. We can talk about the atmosphere. And basically the water and land. So atmosphere can absorb energy, including gases that are in the atmosphere like water vapor, carbon monoxide, methane, and these gases trap heat, and we call this the greenhouse effect because it acts a lot like a greenhouse. You know, a real greenhouse is this glass building. You put plants in there, the light comes into glass, and then the light hits the surface, turns into heat, and then the heat can't escape very well through the glass, so then it keeps the inside of the greenhouse warm, but still lets light in. Our atmosphere does pretty much the same thing. It lets light come in so we get to see, but it keeps the heat from escaping, which keeps us from getting too cold. The problem is that we are producing specifically too much carbon dioxide. Anytime we run a car and we burn fuel, we're making carbon dioxide, and that increase in carbon dioxide has caused the average temperature on the Earth to gradually be increasing. So 200 years ago, the average temperature wasn't quite as warm as it is now, and even 100 years ago. And the concern is that if it keeps gradually getting warmer and warmer every decade, that we're creating a situation that's going to make things too warm and cause problems with life on our planet. So there are some efforts being made to reduce the amount of carbon dioxide that we make. Methane, we have less control over, even though one of the main sources of methane is cows. Basically, when cows eat, some of that gas comes out the other end, and it makes methane. So if we had fewer domesticated cows, we might